Okay, we're going to look at the integration question from 2014, extension 2, HSC. The last question, very last question, question 16, C. Question is, integrate ln x on 1 plus ln x squared dx. Okay, so you would obviously be running through all the possibilities you have for such a question. It wouldn't be a partial fractions. It probably would not be a completing squared. It could be a by parts, but I think the very first thing we would usually try with something like this for by parts, because obviously if you wanted to do by parts, you've got to understand you've got to have a derivative component anyways. You can't differentiate this nicely anyways. Integrate this nicely. So the derivative is okay, the derivative log is fine, but then when you're going to integrate this denominator, for example, you're going to get stuck anyway. So you can't do by parts yet. We might want to change this by a u substitution. So let u equal to 1 plus ln x. Therefore, you get du equal to 1 on x dx. Now, you can see I've got not 1 on x here. So what I've got to do is just change this x in terms of u. So from this equation here, we're going to get u minus 1 is equal to ln x, and then, of course, exponential both sides, so you get x equals to e to the power of u minus 1. So dx is equal to e to the power of u minus 1 du. Okay, because I've moved this x over here. Alright, now let's start substituting everything in. ln x is u minus 1. u minus 1. dx is e u minus 1 du over 1 plus ln x. 1 plus ln x is just u, so u squared. Okay, it looks like a whole lot of things, but of course we will split the denominators up in this case. So we've got u on u squared, which is 1 on u, multiplied by e u minus 1, minus e u negative 1 over u squared du. Now you're stuck again and you're thinking, okay, how am I going to integrate this? In this case, you can actually do by parts. Looks similar to these ones that you've done before by parts. So that's one that you've done before by parts. This one you've done before by parts. In fact, that's where it came from. See, ex on x, eu on u. Leave this for the time being. Let's start with one side first. So we'll start with the left side here. So integral of eu minus 1 on u du. This becomes by parts. So u equals to, we're going to pick u as 1 on u, and therefore du becomes negative 1 on u squared. dv is e u minus 1. v is equal to e u minus 1. Put it in the actual by parts formula, so it becomes 1 on u times eu minus 1. So your integral, so this is your integration as well, so your integral is there. I equals e u minus 1 on u, e u minus 1 on u, minus the integral of negative 1, so there's a negative and a negative, that makes it positive, that's what I usually do there, and that becomes e u minus 1 on u squared du. And that's a good thing, because you can look above, it's exactly what you have here. So your I is equal to this, plus this, but then here, you still got this component which we haven't actually used yet. So if I'm going to subtract e u minus 1 on u squared du, look what happens. This cancels out with this. Next line. Is the answer. Please don't forget, you need to substitute back. So we had u as 1 plus ln x, substitute it back in, e to the power of ln x, because 1 plus ln x minus 1 is ln x over u, which is 1 plus ln x. Final answer, e of log is obviously just x, e of log x is just x over 1 plus ln x plus c. Hope that helped.